Okay, it's 1 o'clock, so let's go ahead and get started today. Afternoon, everybody. How's everybody doing today?
Good. How about yourself?
Good, good. It seems like a lot of people have midterms this week, so hang in there. So again, remember our midterm is next Thursday. So remember, it's going to be a 24-hour exam. So I'm already starting to prep it right now, and then so that'll be ready for you by next week. So I've uploaded a study guide for the exam, so that you can find that on the week 3 or week 5 page on our Canvas site. And also remember that I'm also going to be pre-recording a review session for you guys too. So actually up on Canvas right now is a survey that you can fill out. I'll leave it up until, I do want to film after the lecture today, so I won't leave it up for too long. It's a poll where you can basically vote on which topics that you want to see on the review session. Because, you know, we've covered a lot up to this point, and I don't think I'm going to have time to cover everything in good detail. And so usually what I do for review sessions is I pick 2 or 3 topics, and I really go over them in detail, do another example problem, and kind of explain that thoroughly. And I want to make sure that those topics are the ones that everyone, at least more people are struggling with. So if you get a chance, you know, you can do it right now if you really want. It's just going to take a couple seconds. Just go to the Canvas site and go to the quizzes section on the Canvas site, and then vote on the survey for which topics that you'd like to see in the review session. So I plan on starting to film today after the lecture at 2:30. So if you can fill that out before 2:30 today, then your voice will be heard. So one word of advice though, if you're going to vote in the poll, don't vote on everything, because I've had that happen a lot in the past. Because you know the point of these polls is so I can see relatively which topics are in more need of covering than others. So if you vote for everything, it's kind of like you voted for nothing, because you know that doesn't help me see relative peaks. And so if you're going to vote, I would try to limit it to just 1 or 2 or 3 topics that you'd like to see the most, and then that's usually the most useful for me. Okay? So that's up on Canvas right now, so you can go vote on it right now, or until basically maybe 15 minutes after the lecture ends today, in order to get that. Okay. Any questions on that or anything else before we get started today? Okay. And so the plan for today is that we're going to basically finish up the lecture notes on annual cash flow analysis. So there's not that much left, so I don't think it's going to take the whole time. And then I want to start the next topic, which is rate of return analysis. So rate of return is not going to be on the midterm, and so you'll see that on the study guide too. But you know, I just want to keep things rolling so that we can keep going with the class. Okay, so I think last time on Tuesday we ended with an example. We were about halfway through the example, and so the idea behind this example is performing annual cash flow analysis when you have to do an early salvage. Okay. And so I think we are just about done with the first part, but let's just redo it here again. Okay. And so remember, for this particular problem, we're considering 2 different machines that we want to buy for our company, and we plan to use each of the machines for 10 years. Okay? And so what we want to do is we wanted to come up with an expression for the EUAW, which is the uniform series representation of all the cash flows. And then for machine A can only last 7 years. So at the year 7, we are gonna salvage that machine and buy a new one. And then after 3 more years, we're going to salvage that one at a higher rate. Okay. Always one short. Okay. And so just like, you know, for all these problems, it always helps to write out the cash flow diagram, you know, even if it's you know, relatively simple problem. But the cash flow diagram really does help you to visualize everything, okay? Just to make sure you get everything and you have all the necessary conversions, okay? Okay, and so just like we said, so option A right here, it's only going to last 7 years. So at year 7, we're going to purchase a new one at a price PA, and we're going to salvage our old one at FA. Okay. And then after at year 10, we're going to take our second machine and salvage it for a new salvage value called F3A. Okay. And so what we want to do in order to perform an annual cash flow analysis is to convert all of these guys into a uniform series. Okay. So remember the term that we gave for that is EUAW, okay? And this is for option A. And so first we have the our initial cost here. And so to convert that, we're going to do P over A. Our interest rate was 8% and 10 years. Okay. Plus the let's add in this guy right here. Okay. Everything that happens in year 7. And so this totally is going to be FA minus PA. And so remember, when we are converting this to a uniform series, we can't just straight up do a single conversion here. And so because this cash flow happens in the middle of our timeline, first we need to convert this to the present day. So you can either do present day or at the end, and then from there we can convert it to a uniform series. And so first to convert this to the present day, this is going to be P over F, 8%, and then 7 years. Okay. It's 7 because this guy's take place in year 7. Okay. Oh, sorry. This is not P over A. It should be A over P. A over P, right? Because we're converting to a uniform series. And then the same thing here. So there's going to be A over P, 8%, and 10. Okay. And then finally, we have our final salvage value here of F3A at the end. Okay. So we have F3A, and this is going to be A over F. Okay. We can do this in one shot because this takes place at the very end of our timeline. Okay. Okay. And so that's going to be A over F, 8% and 10 years. And so if we plug in the numbers from the table, what we get is 0.236 PA plus 0.087 FA, okay, and then plus 0.069 F3A. Okay. And so that's our expression there for the EUAW for option A, which has this following cash flow diagram.
Professor?
Yeah.
Isn't the first PA negative?
Yes, thank you. Should be negative. Mm-hmm. Yes, and this also should be negative here. Yep. All right. Any other questions on this? Okay. And so that's option A. And so now let's do option B. Option B is actually a little simpler. Okay. And so in option B, we have a initial cost at the beginning. So we'll call this a minus PB. Okay. And if you remember from last time, option B had a useful life of 13 years. So actually, we don't need to do any selling or buy replacement. And so the only thing that we're going to have at the end here is salvage value. Okay. But since we're salvaging early, this salvage value is still unknown. So we're going to call it F10B. Okay. Okay. All right. And so to compute the EUAW, we're going to convert all these guys into a uniform series. So we have a minus PB, A over P, 8%, 10 years. Okay. Right. And then we have our final salvage value here, which happens at the very end, so we don't need to do anything for it. So we're gonna have plus F10B, okay, A over F, 8%, and 10 years. Okay? And so if we plug in values from the table, we get that EU AW of B is equal to a minus 0.149 PB plus 0.069 F10B. Okay? Right. And so, of course, you know, you can perform these calculations with the formulas too, but with the tables and the fact that our interest rate is a whole number here, it's a lot faster to do it that way. So just keep that in mind. But if you are more comfortable using the formulas, you know, by all means, go ahead and do so. Okay. All right. Any questions on this example here? Okay. All right. And so that's pretty much it for annual cash flow analysis. So you can see, you know, it has a lot of similarities to present worth analysis, except instead of converting to a present sum, you're converting everything to a uniform series. So, you know, all the principles are kind of still the same. Okay? But there's kind of one special topic that I want to cover with annual cash flow, just more from the perspective that I think is useful for kind of personal life. And that's the idea of building an amortization schedule in order to analyze a loan. Okay? And so a loan is probably one of the most common financial transactions that, you know, most people will make, you know, both in their personal life and in their professional life. So, you know, people take out loans to, you know, to buy a house, to buy a car, you know, for your education, you know, all different kinds of loans like that. Okay. And so the idea with an amortization schedule is that it gives you kind of a very organized way and very, you know, detailed way to kind of analyze everything about your loan. Okay. And so the nice thing about this is that it really kind of breaks it down for you. Okay? And so traditionally, you know, especially for a really big loan, you would do something like this in a spreadsheet. And actually, if you have Microsoft Excel, and I think even like Google Sheets or other softwares do it too. But there's specialized functions that you can do to actually build an amortization schedule. But for class today, you know, I'm going to show you how to do this manually, just so you can kind of do your own calculations. Okay? And just like with anything, you know, especially with personal finances, it's you know, what I want to you know, emphasize here, that it's always good for you to kind of check these numbers yourself, because you know, getting a loan, you know, if you haven't gotten one already, is something that's going to be pretty common. And you know, for something as big like this, you never want to trust the numbers that, you know, the banks or whatever that they give you straight up. So do your own calculations, you know, get your numbers, and just to make sure that everything is good. And any kind of discrepancies, you know, you can always talk it up with the bank or whoever's loaning you the money. Okay, greedy uncles or whoever it may be. Okay, so let's draw out first just kind of the template of what an amortization schedule looks like. Okay. Okay, so the first thing for an amortization schedule is the just kind of this I call it like the header section. Okay, so in the header section, you kind of fill out kind of some of the statistics for your loan. Okay, and so first you have your initial balance. Let me use a different color. Okay, and so the initial balance, that's basically the amount of money that you're taking out for the loan, so that you can think of that as like the present day value of your loan. Right? So that this is like a present sum. This is a P. Next, you have your interest rate. So this is just simply the interest rate of the loan. So this is usually something that's given to you. Right, so next is the number of payments. And so this is the, part of the agreement of the loan of, how long you're going to, how many payments you're going to do or how long you're going to, be repaying the loan. Okay. Right. And then the last piece of information is the uniform payment amount. So this is the amount of money that you're going to pay, usually, for these things it's every month. But sometimes it might be every year or something like that. Okay, and so this is basically the uniform series equivalence of your initial balance here. Okay? So this is kind of the first section of the amortization schedule. So this is kind of the first thing that you fill out, just based on the statistics of the loan. Okay, and then from there you kind of launch into the table itself. Okay? So the table has 5 columns. Okay, and let's go over what each of them are. All right, so the first column is the period. So basically, the period just states, what number payment that you're on, okay, or what month it's been, or what year it's been since the loan has started. So usually, this is just a numbered list that goes from 1, 2, 3, all the way up until you reach the number of payments that you've agreed to. Okay. All right, so the next column is the beginning balance. And so this is the balance on your loan at the beginning of this period. Okay. Next is the interest, and so that's how much interest you're going to pay in that period. Okay, and we'll go over how to compute that. Okay, and so the fourth column is going to be principal paid, and so that's how much that's how much of a dent you're actually you can think of as how much of a dent that you're making into your initial loan. Okay, and so the way that we're going to compute that is just the uniform series payment, okay, subtracted from the interest, and I'll write expressions for this later. Okay, and then there's one more column that I can't fit here, but it's basically the end balance. Okay? And so at the end of this period, how much money do you still owe on the loan? And that's going to be your ending balance. Okay? So it's 5 columns. So probably if you guys are writing on a piece of paper, you guys can fit it better. But this is what it looks like. Let me rewrite this just for the. So this column was beginning balance. Okay. All right. Any questions on this?
Yeah, Professor, really quick. Does that say beginning balance right next to period?
Yeah, so it's BEG is beginning balance. Yeah, so that's how much money you owe at the beginning of that period.
Okay, thank you.
Mm-hmm. Okay. Okay, so let's actually put some more precise definitions. So this is just a template. So this is what you're going to be filling in, but what you actually fill into these, let's go over that right now. Okay, so let's start with initial balance. Right. And so the initial balance is how much money that you probably took out from the loan, or you're loaning someone. Okay. And so one way that you can think of this is the present day value of this loan. Okay. So this is a P. All right. And so interest rate is interest rate and number of payments. I think those are pretty self-explanatory. So next, let's go over the uniform payment amount. Right. And so this is the amount of money that you're going to pay, in each pay period. So every month, every year, or whatever the arrangement on your loan is. Okay? And so the way that we compute this is we just simply use our, we just convert our present day value into a uniform series. And so the formula is going to be A is equal to P, A over P, and then you plug in your interest rate, whatever that was, and then N, okay? And so you can either use the formulas to do this, because normally it's not that big calculation, or if your interest rate is something that you can look up in the tables, you can use that as well. Okay, and so let's define all the other values in the table, right? And so period, that's something that's pretty self-explanatory. And so let's do beginning balance. And so this represents the amount of money that's still owed on the loan at the beginning of this period. And so your beginning balance at the first period is going to be your present day value. So it's going to be your the initial balance. And then each period after that, the beginning balance is going to go down as you pay off the principal. Okay. Okay. All right. So now let's do the interest. And so the way that we can compute the interest is kind of similar to when we first introduced the interest payments. And we simply are just going to multiply the beginning balance of that period multiplied by the interest rate. Okay. And what this represents is that this represents how much of your uniform payment amount is going to go towards paying just interest. Okay. And so basically every time that you make a payment, a certain amount of your money is going to go towards paying the interest, while the other chunk will actually go towards paying the amount that you owe. So basically the higher interest rates, the more interest you're going to pay, and the more money you have to pay out overall. Okay. Okay. And any questions on this?
Yes. What's the big difference of this table, this amortization table, and the compound table?
Yeah, so they're very similar actually. So like the examples that we did before, it uses a lot of the same ideas, but this one we were kind of doing it more in the context of like uniform payments amounts. And this is the one that's kind of traditionally more used by like accountants and stuff like that too. And so this is mostly just geared towards a loan and stuff like that. I think the example that we did before was also a loan type of example as well. But this time you're making a payment every period versus I think before, I think our friend was kind of paying us all back at the very end. So this is, how do we break it down for if you're making payments every period? How does that affect your loan?
Okay, thank you.
Yep. Okay. And so next is the principal paid. And so what this represents is how much of your payment is actually going towards repaying the actual loan. Or in other words, how much of this is actually going towards paying off the balance. And so the way that you compute this is you just subtract. And so you take your uniform series payment amount, so your A, and you subtract the interest from it. Okay. And then finally, we have our ending balance. Okay, so the ending balance is the amount left over on the loan after that period. Okay, and so the end balance is simply just going to be the beginning balance of that period minus the principal paid. Okay. And so just naturally, you know, if you're doing an amortization schedule for like a really big loan, like a 30-year mortgage on a house or something, you know, it's going to be a lot easier to do that in a spreadsheet. But you know, we'll do just kind of a few simple examples, and I have you just kind of work through a relatively simple one on the homework as well, just to kind of give you an idea of what these calculations are like. Okay. Okay. Any questions on this before we jump into an example? Okay. Okay. And so let's say that you recently just bought a new piece of furniture, and this piece of furniture cost $2,400. Okay. And then you wanna pay this off in 4 equal monthly payments. So you want to finance the purchase. Okay. Okay. And so the store agrees to your agreement, but they're going to charge you some interest rate. But it's a pretty nice store, so they're only going to charge you a 0.25% interest rate. It's probably the smallest interest rate that you'll see. Okay. Okay, and so in this problem, basically, we want to build our amortization schedule. So first, we're going to compute how much money that we need to pay off every month, okay? And then we're going to fill out the full schedule. All right, any questions on this on the setup for this example here? Okay. Okay, so first, let's compute the monthly payment amount. All right. And so we're going to compute our A here. Okay. And so our A is going to be our initial cost. So our initial cost was $2,400. Okay. And then we're going to convert this to a uniform series. So we need our A over P factor. Our interest rate is 0.25%. And then we have 4 periods. Okay. And so if we look up this value in the table, this is 0.2516. Okay. And so we get a uniform series payment amount of $603.84. Okay. So pretty straightforward. You just basically take whatever the initial cost was or the initial balance on the loan, and then you just convert it to an A using either the tables or the formulas. All right, so next we have our amortization schedule. And so first let's fill out kind of the header portion. And so first we have the initial balance. Okay. And so we know our initial balance is 2,400. Okay. All right, so next we have our interest rate. So our interest rate was 0.25%. And so if we want to put this in decimal form, this is 0.0025. Next, we have the number of payments. All right, so our number of payments is 4. And then we have our payment amount. Okay, so our payment amount is $603.84. Okay. All right, so this is just the header portion here. So this is just to kind of help us keep track of the statistics of the loan. And then from here, we're going to start filling out the table. Okay. All right, any questions on this so far? Okay. Okay, so let's start filling out the table. So first we have the first column, which is period.
We can have this on our midterm, right?
Yes, this is going to be part of the midterm. Okay. And so we have 4 periods here. So we're going to have 1, 2, 3, 4. Right? Our next column here is our beginning balance. Okay. I'm trying to write small just so I can fit everything. Okay. Next, we have our interest. Okay. Next, we have our principal paid. Right? And then finally, we have our end balance. Okay. So I fit it all this time. Right? Okay, and so the way we fill this table out is we usually just go row by row. Okay. All right, so let's start at the first row here. And so our beginning balance at period 1 is just going to be our initial balance on the loan. So our beginning balance here is going to be 2,400. Okay. And so our interest, remember, the way that we compute it is we just take our beginning balance, we multiply by I. And so if we take 2,400 and we multiply by 0.0025, we get $6. Okay. Right. And so in order to get the principal paid, we take our uniform payment amount, and our uniform payment amount was $603.84, and we subtract the interest from that. And so if we do that, we get $597.84. Okay. And then finally, our ending balance. Our ending balance is just our beginning balance minus principal paid. Okay. And so here we have 1,800, 02, and 16 cents. This is a lot easier on the whiteboard. I don't know what I'm going to do because later on we're going to have tax tables that get even bigger than this. We'll cross that bridge when we get there, I guess. Okay, so that's our first row here. So you can see pretty straightforward. And then from there, you just kind of repeat the same calculations throughout. And so our beginning balance for period 2 is going to be the ending balance of period 1. So you're just going to write down again 1802 and 16 cents. Okay. Our interest is just going to be our interest rate multiplied by this beginning balance. So we have 450. Okay. Our principal paid is going to be, again, our payment amount minus the interest. So we have 599 and 34 cents. Okay. And then our ending balance will just be that. Okay. And so from this, I'm just going to keep continuing on and fill out the table. Okay. If you did everything correctly, your ending balance at the end of your last period should be 0, or it should be somewhat close to 0. So, you know, if you're doing these calculations in a calculator, it might not be exactly 0 because you're going to have a round off error, but it should be pretty close to 0. Okay. All right. And so, any questions on this?
Would you mind if you say again how we get the beginning balance? And it's decreased by like 600 almost.
Right, so the beginning balance is going to be the same as the ending balance of the previous period. So you can see here at the end of period 1, our ending balance was 1802.16. And then we just put that as the beginning balance of the next period right there. And that's how much we're going to pay off.
Okay, thank you.
Yep. Mm-hmm. Okay, and so I want to kind of bring your attention to a couple things here. And these are, and this is kind of a trend for all loans. Okay? And so first, let's look at the column for the interest. Okay. And so this one, the interest rate was so low, so it's a little bit hard to see. But you can see, you know, our interest payment starts off, you know, the highest interest that we pay is at the beginning, because that's where our balance is the highest. And then as time goes on, then our interest payments go down. Okay. And so this is true for any kind of loan. So for all loans, you know, the first few payments that you make, you know, they're going to be very interest heavy. But then once you get towards the end of the loan, you know, the interest payments are going to get much less. Okay. And then you compare that to the principal paid, and that has the opposite trend. So the principal paid, you know, it starts out low, and then it gets higher as you get later on because the interest payments are getting less. Okay. And so for some extreme loans, so like a 30-year mortgage on a house, you know, your first few payments are actually going to be 98% interest, and only 2% of your payments actually going to go towards paying off your house. So like when you first see that, it's a little bit demoralizing because like you feel like you're just paying the bank and very little of that is actually going towards your house. But you know, incrementally, slowly over time, then those interest payments will start to decrease, and you're going to pay off more and more of your house. So that's just kind of a trend to look out for these. Okay. And so there's kind of one more thing that I want to go over here. And so one thing, you know, now we've learned how to build kind of a full amortization schedule for this. Okay. And so one other useful trick that you can do is to compute the current balance of a loan without having to go through the whole table. And so this is useful to do because say that, you know, you bought a house maybe 3 or 4 years ago, and then you've been making payments, and you want to compute just quickly, you know, how much is my balance left, or how much of the house do we still have to pay off?
Is this separate from the example?
Wait, say again?
Is this separate from the example?
Yeah, this is separate from the example. Mm-hmm. And so normally, to compute this, it can be a little bit complicated, especially if you haven't taken an economics class. But another way that you can express the remaining balance is that it's simply just the present day value of how many periods are left. Okay. And so the formula for this is we have remaining balance and so this is equal to your uniform payment amount A, and we want to convert this to a present amount. So we're going to do P over A at the interest rate. Okay. And then the N that you plug in there is the number of payments that you have left. Okay. And so to actually compute this, you need to compute, how many payments we have left on our loan, and then plug that in for that. Okay. Okay. And so, just a quick example for the last one, since we have the numbers already for here. Let's say that we've made 2 payments on our piece of furniture, and we want to find out what our remaining balance is. Okay. And so to do that, we're just going to simply multiply A, where our A in this case was $603.84. Okay. And then we're going to multiply that by P over A. Our interest rate was 0.25. And then our N in this case, since we've already made 2 payments, and so we have 2 payments left. Okay. And then this is equal to 1203.45. Okay. And if you compare that to our example where we have the full table already, that's exactly how much of the remaining balance is there after 2 payments. Okay. Close, pretty close to it. Okay. So there's always going to be a little bit of round off error, but you're always going to get within a few dollars or a few cents. Okay. Any final questions on this? Okay. And so that's it for annual cash flow. So this is kind of a stopping point right here for what's going to be covered on the midterm. So I'm going to continue on with the next set of lecture notes, but everything we do from here on until the end of lecture today is not going to be on the midterm. Okay, it'll be on the next midterm though. Okay, and so the next topic that we're going to go over is another type of economic analysis, and it's called rate of return analysis. Okay, and so up to this point, we've covered 2 major economic analysis techniques. So we've done present worth analysis, and we just finished annual cash flow. Right? And so those are kind of 2 out of the big 3 of economic analysis techniques that we'll do in this class. And so the last one here is rate of return. But compared to the first 2, rate of return is a little bit of a black sheep of the family. Okay, because up to this point, basically for every single problem that I've given you so far, we've always assumed that we know the interest rate. And so this was always given to us from the problems that we did. Okay. And so, given that interest rate and given a number of periods, we were always computing some kind of cash flow. So either via present sum or a uniform series or, whatever the problem dictated. And so for rate of return, we're gonna flip this around a little bit. So in rate of return, we're gonna be given all the cash flows. And so we'll be given every single present sum, uniform series, maintenance, salvage, future value that we'll need for the problem. But these problems are not going to be giving us an interest rate. Okay. Right. And so basically, we'll be solving for the interest rate that will cause, all the cash flows in the problem to balance out. And this interest rate right here is known as the rate of return. There's a big thud outside my door, so I forgot that we ordered cat litter. I feel bad because I live on the second floor, and I think the poor Amazon delivery guy has to carry a 40-pound bag of cat litter up to my apartment. So, but there's always just a huge thud, just because probably he was tired of carrying that thing. But Chewy's prices are just too good. Okay, so let's do an example just to kind of illustrate, how we do this. For a second, I'm always scared that someone dumped a dead body in front of my apartment, but that hasn't happened yet. So, okay. And so let's say that we took out a loan, or we're paying a loan off to, we're giving a loan to someone. Okay. And so let's say that a present day value loan of $5,000 is going to be repaid with 5 equal monthly payments. Okay, and the payment amount is going to be $1,252. Okay, and so from this information, let's compute the rate of return. Okay, so that's the situation that we have here. And so, what I'm going to do on the next page is let's draw out the cash flow. It's a relatively simple example, but again, cash flow diagrams means that helps you out with these problems. Especially when we're doing kind of a new problem that we haven't done. Okay. So I'll draw the cash flow diagram and I'll show you how we actually compute this interest rate. Okay. Before I do that, are there any questions on this page or on the example setup? Okay. Okay, so let's draw the cash flow diagram. And so I'm going to draw the loan as a present day cost, but actually, you can actually reverse it, and it's fine. It depends on if you're giving out the loan or if you're receiving the loan. Okay. All right. And so I'm going to draw this from the perspective that I gave a $5,000 loan off to somebody, and then over 5 months, they're going to pay me back at $1,252 each month. Right. Okay. And so the way we're going to set this up is we're going to set up a equivalent cash flow and sum up all the cash flows and set it equal to 0. And so to sum that up, basically, we can convert everything to the same form. Okay. And so we know that when we convert everything to the same form, we can just simply add them up together. Okay. Okay. And then set it equal to 0. Okay. And so just because, it's usually the most convenient, let's convert everything into a present sum. Right? And we'll say, so we'll have 0 on one side of the equation. Okay. And then we have a minus 5,000. And so that's already in present day form, so we don't have to do anything for that. Okay. And then we're going to add 1,252. Right? And so to convert this to present day form, we have P over A. We don't know the interest rate, so we'll leave it that as an unknown. And then our time period is 5. Okay. Right? And so our only unknown here is this quantity right here. And so let's solve for it. Okay. And so if we add 5,000 to the other side, divide by 1,252, then we get P over A, I, and 5 is equal to 5,000 divided by 1,252. Okay, and we get 3.994. Okay. Okay. And so if you want to solve this with the compound interest tables, all you have to do is basically look up in the compound interest tables and find the factor that has that's 3.994. So look in tables on, and remember we're on 5 periods here. So remember you're checking the fifth row in the matrix. And so if you're gonna look in basically the P over A column, and then the N is equal to 5 column, and see what that factor is, and then keep searching through all the tables until you find the one that's closest to 3.994. Okay. And so this is, of course, tedious, and so but this is kind of one way to do it. And so basically, you're going to scroll through all the tables until you find one which is 3.994. Okay. And then for this one, since I've already done this, I know that you're going to find this this value here on the interest table for 8%. Okay? And so if you look on the compound interest table for 8%, and you go to the N is equal to 5 row and the P over A column, then you're going to find 3.994. Okay? And so this is kind of one way that you can do rate of return analysis when the numbers are really nice. Okay. Any questions on this?
Yeah, I have a question.
Yeah, what's up?
So if the number 3.994 is right like in between two numbers, do you want us to interpolate?
Yeah, actually that's exactly what I want you to do. So so we'll get to that kind of later on in the lecture notes. But yeah, when you get a factor that's kind of in between two tables, then the best way to do that is to interpolate between the two. Yeah.
Okay.
Mm-hmm. Okay. And so, that's basically the idea of solving rate of return analysis using the compound interest tables. But this process can be pretty tedious if you don't really know where to start looking. And so, if you open up the compound interest tables PDF, you'll notice that there are 32 pages, and 32 pages full of just tons of numbers. So if you have no idea where to start looking, and you start looking at the very beginning of the table, a lot of times you're going to be doing a lot of scrolling for these kinds of problems. And when the problems get a bit more complicated too, with more cash flows, it becomes even more difficult. So there's other ways that you can do it. Okay? And so actually, for these kinds of problems, if you've been keeping up with the practice with the formulas, doing it with formulas is actually another great way to do this too. Okay. And so let's set up our same thing. Okay. So we can say that a present worth of our loans, we have a minus 5,000 plus 1,252 times P over A, I, and 5%. Okay. And so for this right here, let's plug in our formula for P over A. And so when you're using these formulas, basically, and when you're plugging in for these kind of terms in parentheses, you just divide both. You just divide both sides so that you just get the factor over there. Okay. Yeah, interpolation is a bit tedious. Yeah. So this rate of return, no matter what method, no matter what path you choose for rate of return, I'll tell you right now that it's going to be tedious. So that's why this one is actually rate of return is people actually like this one the most, but of course it's always the most difficult one to do. But yeah, it is tedious, kind of no matter what path that you choose. Okay, so our P and A formula looks something like this. So it's 1 plus I to the n minus 1 all over I, 1 plus I to the n. Okay. And since we know our n is equal to 5, we can go ahead and plug that in. Okay. And so we got our present worth is equal to minus 5,000 plus 1,252 times 1 plus I raised to the 5th power minus 1 all over I, 1 plus I to the n. Okay. And so what you can do is you can set this equal to 0 and solve for I. Okay. And so of course I'm just kidding, because this is this thing right here is not fun to solve for right here. So being able to isolate I from these, will really take some algebraic gymnastics in order to do that, if you can even. So actually, I don't think for this one you can even do that, because you have I and I over there. And so, that doesn't mean the formulas are useless here. And so, what you'll notice here is that I set everything in terms of PW here, where, on the previous page, I set this equal to 0. And so the reason I set this equal to PW is that you can take this formula here and you can plot it. And so you can either plot it in, you can plot it in Excel if you have a spreadsheet open, or if you're good at plotting in MATLAB, you can plot this in MATLAB too. I have to always stop myself, because I always, when I was, for me, the only the most spreadsheet I've used the most by far is Excel in my life. But I know people use like Google Sheets and other stuff now, so I have to stop myself from saying Excel and say spreadsheets. Okay. And so, of course, MATLAB is not a requirement for this class, so you don't have to use it. But in case you were curious on how to solve this with MATLAB, I'm going to give you just the basic code for it. And so first we got to define our interest vector. Okay. And so basically it's what we're going to plug in for I over here. Okay. Okay. And so we need to, if we're going to plot this for certain values of I, we need to be able to define what values of I that we're going to go over. And so this is just one way to do it. Okay. All right. And then from there, we can put in our formula for PW. And so basically, we're going to input this entire formula here for PW, right? And so PW is going to be minus 5,000 plus 1252. And then this is going to be multiplied by, and we have 3 parentheses here, actually. So we have 1 plus I dot a caret to the 5 minus 1, okay, close parentheses, dot divide by I dot star 1 plus I dot caret 5, and then 2 close parentheses, and then a semicolon. Okay. And so basically, all I did here was I just input our present worth formula into MATLAB code, and so now that we can plot it. Okay. So again, you don't have to do this. This is just if you were curious and you want to do these problems with MATLAB, this is how you would kind of set it up. Okay. Okay. So there's 2 more lines of MATLAB code, and then I'll draw you what the plot looks like. Before I do that, are there any questions on this page?
I'm just wondering if we get a question like this for homework or on a test, how should we show our work? I know in MATLAB or something we could take a screenshot and post that, but what if I graph it on like a graphing calculator? Should I just sketch the graph?
Yeah, I would sketch the graph. If you can give me maybe a few values of like the present worth, say like the present worth at interest rate 7, interest rate 6, 8, and then just kind of show me what you computed, then that would work too. Yeah.
Okay.
Okay. So yeah, graphing calculator also another great option for these as well. Okay, and so the final 2 lines of MATLAB code for this would just be plotting it. Okay, so first we have to create a figure. Okay. I know you don't have to do this, but I like to create all my figures because I've had MATLAB codes with lots of different figures in there. Okay. And then you just simply plot. Okay. And so you plot the x vector. So our x vector here will be our interest rates, and then our y vector here will be our present worths. Okay. And the plot will look something like this. Okay. And so we have 300, 200, 100, 0. Okay. So 0 is going to be our most interesting line here. And because basically what we want to find is where our function for the present worth crosses 0. Okay. And then down here we have 0 0.06, 0 0.07, 0 0.08, 0 0.09, and 0 0.1. Okay. And so the graph would look something like this. And so since we know that it crosses the axis 0.08, it's going to be like that. Okay? And so basically the way that you interpret this graph is that you look at the location where your graph is going to cross, y is equal to 0, and then that's going to be your rate of return. Okay. So two different ways to solve these problems. You can either use it with the tables, or you can do it with with some kind of graphing software here. Okay? So I will say that I think more people generally use the tables, just because it does take a little bit of time to set this up in like a MATLAB code or in your graphing calculator. And with the tables, usually for these problems, I'll give you an approximate place for where to start. So say start looking around, interest rate 10 or something like that, and then that will get you pretty close. Because otherwise, with the tables, you'd have to be searching from the beginning, and it's usually kind of tough. Okay? But use whichever one that you want. So use whichever method that you is more comfortable for you, because all of them will get you the same answer. Okay. Okay. Any questions on this? Okay, so let's dive a little bit deeper into different ways that we can actually compute or calculate rate of return. Okay, And so in the previous example, what we did was we basically treated it as if it were like a present worth analysis. And so we converted everything into its present day value, and then we summed them up, added them equal to 0, and then we found our interest rate from there. Okay. But there are actually other ways that you can actually do that. Okay. And so the way that we just did was basically this one right here. So we would compute the present worth of all the benefits. Okay. And then we subtract that from the present worth of all the costs. Okay. And then we just set that equal to 0. Okay. And so that's basically just what we did just now. Another way that you can do it, which is just kind of a spin off the previous formula, is you can do present worth of the benefits divided by present worth of the costs, okay, and set that equal to 1. Okay, and then solve for basically the interest rate that will make these two guys make this ratio equal to 1. Okay. Right. Another way that you can express the first equation, you can just say that the net present worth that's equal to 0. Okay. And then the last way you can do it is you can do it in terms of annual cash flow analysis. So you can do the EUAW, okay, or the equivalent uniform annual worth, and set that equal to 0. Okay. And this is the same thing as the EUAB, which is the equivalent uniform annual benefits. So the uniform series for all the benefits in your system, and you subtract the EUAC, which is the equivalent uniform annual costs. Okay, so all of these guys work. So it's really just up to you, depending on which way you want to set it up. But for me, usually the either number 1 or number 3, you know, which are basically the same thing. Those are kind of the easiest for me to do. But you know, again, you know, no matter which method that you choose here, you're going to end up with the same thing. Okay. Okay. All right, any questions on this? Okay. Okay, so let's do another example. Okay. And so let's say that we have a cash flow diagram that looks like this. M9, sorry. Okay. And so let's say in years 0 through 3, we have a benefit here. And so all these guys have the same value of 9,000. All right. And then in years 5 through 9, we have a decrease. And so everything in green right here will be 8,316. And so for this problem, what we want to find out is what is the rate of return? Okay. Okay. And so basically we're gonna just follow kind of the same methods that we have here. And I think in this problem, I solve it with the tables. Yep. And then we'll see, and this problem we'll actually have to interpolate. So we'll see how that works too. Okay. And so I think probably we'll have enough time to start it, and then we'll finish it up next Tuesday. Okay. Any questions on the problem setup? Okay. Okay, so first, let's decide how we want to go about this. And so the way I'm going to go about it is I'm going to compute the present worth of everything. Okay. Okay. And so let's take all of our cash flows here converted to present worth. Okay. But for this problem, you know, and I chose this problem on purpose because it can be really tricky. Okay. And so what we have in red right here is what looks like a uniform series, right? And so it's tempting to basically just say that, you know, okay, the present day value of this is going to be 9,000 times P over A, I, which is our interest rate, and 4. Okay. And so it's really tempting, but you know, you'll notice that the very first entry here for this 9,000 is actually on year 0, right? And so this is typically not the case for a uniform series. So as uniform series usually start in year 1, right? Because that's when the recurring costs and benefits usually occur. And so we actually have to split this 9,000 per year into 2 different cash flows. Okay. And so the first thing we have is a cash flow of 9,000. And this is a present day sum because it occurs on year 0. Okay. And then the second way we're going to break this down is a $9,000 per year for years 1, 2, and 3. Okay. And so this is going to be an A. And so out of that initial you know, 4 9,000s in a row, we actually have to split this up into 2 like this in order to get it to be correct. Okay. Okay. And then the last one that we have is a uniform series of 18,000 per year, of 8,360. Okay. And this is only in years 5, 6, 7, 8, and 9. And then what we know about this is because it's a uniform series that starts, you know, much later in our timeline, we have to do multiple conversions here. So this is going to be a non-standard cash flow. Okay. And so let's write out the formula here. All right. So our present worth is equal to. First, we have our 9,000. And so since this 9,000 is already in a present day sum, we don't have to do anything to it. Okay, so it's just going to be 9,000. Okay. And then to that, we're going to add the 9,000 uniform series that occurs on years 1, 2, and 3. So this is going to be 9,000 P over A, I, we don't know I yet, and 3. Okay. And then from this, we're going to subtract 8,316. Okay. And then we need to do 2 conversions here in order to get it into the true present day sum. Okay. And so first, we're going to take that uniform series and convert it to a single sum on the year before it began. Okay. And so the year before it began is going to be year 4. Right. And so this is going to be P over A, I, and then this uniform series occurs for 5 years. Okay. And so this converts it, single sum, in year 4. Okay. And so now we have to take that single sum in year 4 and bring it back to year 0. So this is going to be P over F, I, and then 4. And so this is our total expression here for the present worth, right? And so you can see there's a lot more going on than our previous one, where we can't just simply solve for one factor. And so what we're going to do on Tuesday is we're going to take this expression, plug in these factors here from the different tables, and then find the one that gets us close to 0. And what we'll find is that it's actually going to be in between two different factors. And so we're going to have to interpolate. Okay. So that's all we got time for today. So, I'll stick around if you have any more questions. But remember, there's the poll that's on Canvas right now. So if you go to Canvas and you go to quizzes, and you can vote on what topics you'd like to see on the midterm review. Right? And so I plan on starting the filming on the midterm review like maybe 2:40-ish. So if you could fill that out right now, then your input will be used for the midterm review. Okay. And so remember, I'm going to basically pre-record that and then post that up on Canvas, so you guys will have that to study for the exam. Okay. But that's it for me. So thank you guys, everyone, for tuning in. Have a great weekend, and I'll see you on Tuesday.
Thank you, Professor. Bye.
Thanks.
Hey, Professor. The minute, what are they called? The minute questions or something?
Yeah, there's no minute paper this week, so instead it's going to be just the midterm review poll. Okay. I want you guys to fill that out just so the review will be useful for everybody.
Also, just wanted to make sure because I did miss one. They're not graded, right?
No, they're not graded. Yeah, they're totally.
1 point. That's why.
Oh yeah, they're ungraded and they're anonymous, so I don't even know who answers them or not.
Okay.
But, yeah, those are just
sure.
just for me.
All right. Thank you.
Yep.
Professor?
Yep. Mm-hmm.
For the study guide, I tried to open it, but I couldn't. I don't know why.
Oh, let me check. Yeah, I threw that up kind of right before the lecture. Let me see. Study guide. Oh, that's weird. Yeah, I'll re-upload it and then I'll actually let me do that right now. Files.
All right, thank you. And
Yep.
for the exam, on the syllabus, it says Thursday, 29th.
Yeah, it's a typo. So it's gonna be Thursday, October 2nd, October 1st. Yes. Yeah.
Okay,
So
that's awesome. Thank you so much.
Yep. Mhm.
Thank you.